Hello students, I hope everybody you have done your homework. How are you? Are you studying properly? You are good students. I am sure that you are doing your task properly. My dear children, previous day we have completed many things like as laws of chemical combination. Tell me students, laws of chemical combination. That is law of conservation of mass, law of definite proportion, law of multiple proportion, Dalton's atomic theory that we have learned. Now students, what is the name of the chapter? Yes, you're absolutely right. The name of the chapter is Some Basic Concept of Chemistry. What is chemistry? Chemistry is the branch of science which deals with the study of the elements and their compounds. Students, what is element and what is compound? Element is the pure substance. Compound also is the pure substance. Element is made up of same kind of atom and compound made up of different kind of atoms, but the atoms are combined in the fixed ratio of their mass. Carbon is element, but carbon dioxide is compound. Hydrogen is element, oxygen is element, but water is compound. Hydrogen peroxide, H2O2 is the compound. So basic concept means that atoms, molecules, elements, compounds, mixture, homogeneous mixture, heterogeneous mixture that you have to study. We have learnt in this chapter how reactants combine together to form the compound. And different type laws for this we have learnt. And today we will discuss the concentration of the solution. That is, we have to learn in this chapter law of definite proportion we have completed, multiple proportion completed, Gay-Lussac's law of gaseous volumes, that is the reactant is gas and the product also gas. In this case, this law is applicable where the statement is like this: the volume of the reactant and product, the ratio, that is the ratio of the volume of the reactant and products which are in the gaseous state always bears the simple whole number ratio. That is when water is formed from hydrogen gas and oxygen gas. Then water vapor is formed, and in this case this law is applicable. Another is hydrogen gas and chlorine gas when combined to form the hydrochloric acid gaseous state, then also this law is applicable. Avogadro's law we have learned, that is equal volume of gases contains equal number of molecules at standard temperature and pressure. We have already discussed this. Dalton's atomic theory also we have learned. What is atomic mass? What is molecular mass? We have learned. What is the molecular mass of water? That is near about 18 gram. That also we have learned. Mole concept we have learned, we have discussed. Limiting reagent we have discussed. Now today very important things, that is concentration in solution we have to learn. Solution means it is the binary mixture where two components are present. One is the solute and another is the solvent. Solute is present in the less quantity and solvent is the component of the solution which is present in the large quantity. So solute is one component in the solution and solvent is another component of the solution. And sucrose or sugar, if we take and water is mixed up, then the water and sugar solution we get. So sucrose, C12H22O11, it is the formula of sucrose. And water, when dissolved, then sucrose gradually dissolve in water. So sucrose water solution we get. Now what is concentration? Concentration means number of moles of the solute divided by volume of the solution, divided by volume of the solution. So concentration, solute by solvent, that is solute number of moles and volume of the solution, and concentration is equal to N by V. What is N? N is the number of moles of solute. What is V? V is the volume of the solution. Okay, so students, different units of solution, different units of the concentration of the solution we have to know. First one is mass percent, second is the mole fraction, third is the molarity, and fourth is the molality. So mass percent, mole fraction, molarity and molality we have to learn, my dear students. What is mass percent? So mass percent is equal to mass of the element by total mass of the compound into 100. Into 100. Mass of element divided by total mass of compound into 100, and this is the mass percent of a compound. Suppose if 5% sugar solution, what is the meaning of it? That is 5 gram sugar dissolved in 95 gram of water. So mass percent of a compound is given by the formula, that is mass percent equal to mass of the element divided by total mass of compound into 100. And mass percent is used by only binary solution. What is the meaning of binary solution? What is the meaning of binary solution? Binary, bi means two. When two components are present in the solution, then the solution is known as the binary solution. It is used for calculation of very small quantities. In the right side, you have seen that is solute, as for example sugar, and it is solvent, that is water, and sugar solution is from here. So, first unit of the concentration that we have learnt, mass percent. Second unit is the mole fraction. What is mole fraction? Mole fraction, it is defined as the ratio of the number of moles of a particular component of total number of moles of the solution. If a substance A dissolve in substance B and their number of moles are Na and Nb respectively, then the mole fraction of A and B is Xa and Xb. Again I am repeating, students, if two components present in a solution A and B, and number of moles of A is Na and number of moles of B equal to Nb. So what is the mole fraction of A? A mole fraction is denoted by Xa and B mole fraction is denoted by Xb. So Xa, what is Xa? Xa is equal to Na by Na plus Nb. Just here written, Xa is equal to Na by Na plus Nb, and Xb is equal to Nb by Na plus Nb. Or one thing, students, I am telling you, suppose in a solution there are 100 components, but the sum of the mole fraction of all the components is equal to 1. Suppose there are 10 components, A, B, C, D, E, F, G, H, I, J, total 10 components. So students, sum of the mole fraction of the 10 components is equal to 1. That is Xa plus Xb plus Xc plus Xd plus Xc plus Xf plus Xg plus Xh plus Xi plus Xj. That will be 1. Here two components are present, so Xa plus Xb equal to 1. So if we know the mole fraction of one component, then we can calculate the mole fraction of other component. Suppose if I tell you the mole fraction of Xa is equal to 0.5. So what is the mole fraction of Xb? Answer is 1 minus 0.5, that is 0.5. So it is the mole fractions of the component present in a solution. So one component, one unit I have discussed, that is mass percentage, and second I have discussed here mole fraction. And next, students, just you have seen there gas and liquid, versus gas and liquid here. And next is the molarity. What we have to know? What is molarity? Molarity means it is also the unit of the solution. It is also the unit of the solution. And one thing I am telling you students, when you do the practical in the laboratory, you have to use the unit of concentration molarity. And molarity is used to prepare the solution of a substance. So what is molarity? Molarity is the number of moles of solute divided by volume of the solution. It is most widely used unit and it is denoted by capital M, and it is defined as the number of moles of solute in 1 liter of solution. Therefore, molarity equal to moles of solute by volume of solution. What is moles? What is moles? Anybody, do you know the definition of moles? Yes, you are absolutely right. Moles equal to given mass by molar mass. Moles equal to given mass by molar mass. Suppose if I tell you that 5 gram water means, what is the moles? If you convert 5 gram water in moles, what will be the value of it? So moles in 5 gram water is equal to 5 by 18. That is, given mass is 5 gram and molar mass is 18 gram. So number of moles equal to 5 by 18. So molarity is equal to moles of solute by volume of solution. Moles of solute by volume of solution. In liter. Suppose the volume of solution is given in milliliter, then you have to convert the milliliter into liter unit by dividing thousands. So molarity of a solution depends upon temperature because molarity, this is very important question students. The questions is coming in exam, why molarity depends upon temperature, or which unit of concentration depends upon temperature? Answer will be molarity. Because students, just to see here, molarity definition there is volume, and volume is directly proportional to temperature. According to Charles' law, that is in chapter 5, we have to know the stats of matter. There is one law, Charles' law. And Charles' law according, V directly proportional to T. So molarity varies inversely proportional to volume. So molarity equal to moles of solute by volume of the solution, and volume is directly proportional to temperature. That's why molarity depends upon the temperature. This is very, very important questions. Next, I am going to the molality. Students, molality is denoted by small m. Molality is denoted by small m. And molarity is denoted by capital M. Molarity, R for red. So molarity denoted by capital M and molality denoted by small m. What is the definition of molality? And molality is equal to moles of solute by mass of the solvent. My dear students, you have seen that in the definition of molarity, moles of solute by volume of solution. But here, the moles of solute by mass of the solvent. This is the difference between the two unit of concentration, mass of the solvent. Just to see in the right side, X moles of the solute, and when dissolved, N kg of the solvent. So what is the molality? That is X by N. One thing you keep it in mind, that is the amount of the solvent is in the unit kg. Suppose the unit is given in gram, you have to convert gram to kg. So this is the difference of molarity and molality. Now, molality of a solution does not change with temperature. This is very, very important things. It does not change with temperature because you see that in the formula, no temperature term is given here. So it is independent of temperature, but molarity is dependent of temperature. So now next is two main concentration of solution. Two main concentration of the solution is that we have to know. Two main concentration of the solution. Molarity and molarity. two main concentration of the solution like as the molarity and molality. You have to know the difference between the two. It is most widely used unit denoted by capital M and molality is denoted by small m. Molarity equal to number of moles of solute by volume of solution and molality is equal to number of moles solute by mass of the solvent. Molarity is not preferred. Molality is preferred. Why? Because molarity depends upon temperature, so it is not preferred unit. But molarity is the preferred unit, students. Concept in molarity. In some cases, to find the mass of certain compound, volume of compound, mass of the second compound and volume of the second compound will be given in such case. We apply the formula M1 V1 is equal to M2 and V2. What is M1 and what is V1? M1 is the molarity and V1 is the volume, and second component molarity is M2 and the volume is V2. So formula is M1 V1 equal to M2 V2. This is very important formula. We will do many numericals using this formula, my dear students. Another very important formula used in molarity finding is, so this is very important formula, molarity is equal to percentage. That is the percentage of the solute into density of the solution into 10 divided by mass of the solute. Percentage of the solute of the solution into density of the solution into 10 divided by mass of the solute present. This is very important formula, students. Now example questions. Commercially available sulfuric acid contains 93% by mass. So sulfuric acid solution we have to use. And 93% by mass of sulfuric acid is present and density of 1.84 gram per centimeter cube. Calculate the molarity of the solution and the volume of concentrated acid required to prepare 2.5 ml of 0.50 molarity of sulfuric acid. This is the numericals. So first of all, students, you can calculate the molarity of the solution using the formula percentage. Percentage is 93%. Density is given here into 10 divided by mass of the solute, that is sulfuric acid. And sulfuric acid mass is 98 gram. So molarity of the solution you can calculate here. Next is what is the molarity of a solution containing 0.32 moles of NaCl in 3.5 liters. So direct formula here, the molarity is equal to 0.32 divided by 3.4 liter. 3.4 liter. So this is the molarity. So molarity value 0.094. 0.094 molar NaCl solution. So this type questions is very easy questions. So number of moles of solute is given, volume of the solution is given. So moles of solute divided by volume of solution, that is the molarity. That is the molarity. Examples on molarity. What is the molality of a solution consisting of 1.34 milliliter of carbon tetrachloride? Density is given in 65.0 ml of methylene chloride. Density is also given. So what is the molality? First of all, molality equal to number of moles of solute by amount of solvent in kg. Amount of solvent. So what is given in the questions? CCl4. Number of moles we have to calculate. 1.34 milliliter, 1.59 gram moles. So what is the molality of a solution consisting of 1.34 milliliter of carbon tetrachloride in 65.0 milliliter of methylene chloride? Okay, so step number 1 is like this, step number 2 and step number 3. We will discuss such type questions, molarity and molarity, and I hope your problem will be calculated. So first step, moles of carbon tetrachloride. Second step, calculate the mass of methylene chloride. And third step, calculate the molality. So here carbon tetrachloride is the solute. So number of moles of solute you have to calculate. Number of moles of solute. And next is calculate the mass of methylene chloride. Mass of methylene chloride here 0.08645 kg. And molality, number of moles of carbon tetrachloride here 0.013851 mole. 0.013851 mole. So it is the moles of solute. Here solute is CCl4 carbon tetrachloride and solvent is methylene chloride. Solvent in methylene chloride, that is amount is 0.08645 kg. So what is molality? The number of moles of solute divided by amount of solvent in kg. So if divide moles is this divided by amount of solvent in kg, then we get 0.160 molal. So this is the answer. So first of all, answer how you will get? First you calculate the number of moles of carbon tetrachloride, that is the solute, and second amount of the solvent, that is methylene chloride. Now divide the two, number of moles and amount of solvent, and we will get 0.160 molal. So this is the this type numericals we have to do, my dear children. Molarity, molality, mole fractions, unit related, that we have to do the numericals. So many numericals we will do today up to this. And next video we will do the next topic. Thank you students for watching the video, and I hope that you will get the good marks in the exam, and few questions as an assignment I will give and you will do it, and I hope you will do it and you will do completely. You will do all the questions answers that already I have discussed. Yes or no? Yes. Very good students. Okay, thanks. Bye.